Supernovas are a big, giant, dramatic end to a star's life.
It's so easy to think of our sun as this incredibly gigantic thing. But our sun is absolutely tiny compared to some of the giant stars in the sky.
Scientists detect supernova 570 billion times as bright as our sun. A small, bright object that first flared up in June could be the brightest, most powerful supernova ever spotted by astronomers. If it is indeed a supernova, the object Assassin 15LH pushes the upper limits of what scientists thought exploding stars were capable of. And if it's not a supercharged supernova, it may be something even more mysterious.
We are the product of not just one stellar explosion, but many stellar explosions, and the atoms in our left hand probably came from a different star than our right hand. The carbon, nitrogen, oxygen, and iron, all of that was only created in stars. And the only way it could get here on Earth is if those stars exploded and that material was later amalgamated in our solar system.
The brilliant cosmic explosion, 200 times as powerful as the average supernova, 570 billion times as bright as our sun, and 20 times as bright as all the stars in our Milky Way galaxy combined, even though it only spans 10 miles across, is described in a study published in Science Report. It was spotted 3.8 billion light-years away using the All-Sky Automated Survey for Supernova, an international collaboration headquartered at Ohio State University that uses telescopes around the world to keep an eye on the entire visible night sky. A supernova that bright must have a massive star exploding at its center.
Think about the entire mass of a star that has been held up by nuclear reactions inside. All of a sudden, those nuclear reactions go away in a split second. Everything rushes into the middle. And that sets off the most dramatic explosion in the universe.
The researchers who have studied the blast believe it might be fueled by the death of a magnetar, which is a neutron star with an extremely powerful magnetic field that could theoretically magnify the power of an explosion. But Assassin 15LH's brightness pushes the upper physical limits of that theory, coming dangerously close to upending it entirely. In fact, during the first 4 months since the supernova's discovery, it's released as much radiation energy as our sun would release in 90 billion years of shining. According to Subdong, an astronomer at the Carley Institute for Astronomy and Astrophysics at Peking University, it proves very challenging for one of the most popular models for the engine of paraluminous supernova, the magnetar model, to explain. In addition to being unusually bright, the supernova comes from a neighborhood off the beaten path. Most paraluminous supernovae come from galaxies smaller and dimmer than the Milky Way with high rates of star production. But Assassin 15LH seems to sit in a galaxy more luminous and massive than our own. Paolo Mazzola, a researcher at the Liverpool John Moores University Astrophysics Research Institute, agreed that the object is most likely a supernova. Clearly, this must be a very rare event. But I do think it's a supernova, he told the Post. It would be a challenge to get a magnetar to that level of brightness, he said. The star would have to spin 1,000 times a second and convert that energy into light with almost perfect efficiency, according to the authors of the new study. But it's not impossible. Because Assassin 15LH is so unusual, astronomers will have to continue to study it in the hopes of pinning down its identity for certain. It could turn out to be a totally new phenomenon. Vital clues will emerge as the explosion fades out. How Assassin 15LH fades will reveal much more about this event, and many groups of astronomers are intensely observing this object. There are many ground-based and space-based observatories following the evolution of Assassin 15LH at many wavelengths, all the way from the radio through the X-rays. As the light from Assassin 15LH fades, Shape explained, scientists will have a better chance of seeing the object at its core. They'll also be able to figure out where it's positioned within its host galaxy. If it's in the galaxy's center, it might not be a supernova at all, but rather the result of some kind of unusual black hole activity. Supernovae shape the universe we live in, and there are still many unanswered questions about these explosions, even for the common ones, Shape said. Most of the elements in the world around us that are not hydrogen or helium were either created in supernovae explosions or distributed by them. Supernovae also fundamentally change how galaxies evolve when they explode by ejecting energy and momentum into their surroundings. So, the study of supernovae, especially one pushing at what the laws of physics will allow, can help scientists understand why the universe looks like it does today. The good news is that Assassin 15LH is bright, so it is relatively easy to get high-quality observations, Dong said. Not only us, but many other groups of astronomers are using some of the most advanced telescopes, ground and space-based, to study Assassin 15LH. I am sure that in the near future, we will understand much more about it. Till then, stay curious and keep supporting.